Let's build this RAG app with a sleek interface that queries your own private data securely. All this runs on AWS for about $1 a month with moderate usage. This is built using AWS Bedrock, AWS Lambda, Pinecone as a database, and Streamlit for the UI. Okay, so what's a RAG, you might ask? RAG stands for Retrieval Augmented Generation. The R, or retrieval bit, means that you query your own private knowledge base, which in this case is a bunch of text documents hosted on AWS S3. Then this information is used to augment or to provide context to an LLM when you write a prompt. This is the A part in a RAG. And finally, you have generation, which means your LLM, which could be any LLM model like ChatGPT, Llama 3, or Claude, uses the augmented input or context to generate responses relevant to your private data. First, let's build the knowledge base using AWS Bedrock. Here's how this part fits together. You store your private data in text files on AWS S3. Then AWS Bedrock processes these documents by using an embedding model like the Titan Text Embeddings model. And what this embedding model does is it creates embeddings for sections of text. Each section of text will be converted to an array of numbers which represents that section. For instance, the words cat and kitten could each be stored as arrays of numbers that are very close to each other in a mathematical sense. And Pinecone organizes and stores data in a way that it can quickly find similar embeddings when you search for a term. Once these embeddings have been created, they are stored in Pinecone. So let's build the AWS Bedrock knowledge base. The first step is to create an AWS S3 bucket. This is where we'll store our private data. On the AWS console, I'll search for AWS S3 and go to the S3 console. Then I'll click Create Bucket, give it a name, and click the Create Bucket button at the bottom of the page. Then I'll search for my bucket, click on my bucket, and under the Properties tab, I'll copy the ARN for the bucket. The second step is to sign up on Pinecone. I'll click Create Index, and I'll give my index a name. I'll enter 1024 under Dimensions and select Cozine as the metric. Under Cloud Provider, I'll select AWS and I'll choose my region. Then I'll copy the host because I'll need this later. Next, I'll create an API key. I'll click API Keys and create a new API key by clicking Create API Key. I'll give it a name of AWS and click the Create API Key button to create it. Then I'll copy the API key. The third step is to create an AWS Secret Manager secret to store the Pinecone API key. AWS Bedrock needs an AWS secret for the Pinecone integration. I'll search for Secrets Manager on the AWS console and open the Secrets Manager console. Then I'll click the Store a New Secret button. Under Secret Type, I'll select Other Type of Secret. And under Key Value, I'll enter API Key as the key. The key has to be API Key because that's the key that AWS Bedrock will be looking for. And I'll paste the value of the Pinecone API key I created earlier. Then I'll click Next, and under Secret Name, I'll give it a name. I'll refresh the Secrets Manager console, click on My Secret, and copy the secret ARN. In the AWS console search box, search for Bedrock and go to the AWS Bedrock page. Then click the Get Started button. In the left-hand pane, under Builder Tools, click Knowledge Bases. Then click Create Knowledge Base. I'll give my knowledge base a name. And under IAM, I'll select Create and Use a New Service Role. And I'll give the IAM role a name. Under Choose Data Source, ensure that Amazon S3 is selected. And then click Next. Under Data Source Name, I'll give it a name. Under S3 URI, I'll click Browse S3. and then I'll select the bucket I created earlier. Then I'll click Next, and under Embeddings Model, I'll select Titan Text Embeddings version 2. Under Vector Database, if you choose the OpenSearch Serverless Vector Store, it's going to cost a bit of money. So I'll choose the Choose a Vector Store you have created option, and then select the Pinecone option. Then I'll check the checkbox to agree to the terms of service. I'll paste the Pinecone endpoint URL of the Pinecone database. For AWS Bedrock to connect to Pinecone, it needs to read the API key from an AWS Secrets Manager secret. So I'll paste the ARN of the secret I created earlier. Then under Metadata Field Mapping, I'll enter text under the text field name. And for the metadata field, I'll enter metadata. Then I'll click Next. And then I'll click Create Knowledge Base. Now I'll go to the S3 bucket I created earlier, and I'll upload some private data. Then on the AWS Bedrock page, I'll select my data source and click Sync. After the sync completes, I'll click Select Model in the right-hand pane, and I'll choose Claude 3 Haiku as the LLM. I'll ask it to list all of my llamas, and we get results along with details of where the results came from. Now that we have a working RAG on AWS, let's create an AWS Lambda, which will query AWS Bedrock. We'll invoke the Lambda with a POST request, and the Lambda will in turn invoke the AWS Bedrock API using the retrieve and generate command. What this command does is it will convert the prompt into a vector embedding using the Titan Text Embeddings model, and then pass that vector embeddings to Pinecone. Pinecone will then use that vector embeddings to query for closely matched embeddings and return results in text back to AWS Bedrock. And finally, AWS Bedrock will take the text results it received from Pinecone and augment the prompt with this information as context and query the Claude Haiku LLM. The results are then returned to the Lambda. To create the Lambda, I'll go to the AWS Lambda console, and then I'll click Create Function. I'll make sure Author from Scratch is selected and give the function a name. For runtime, I'll select Python and leave the architecture as x86. Under Advanced Settings, I'll check Enable Function URL. And under Auth Type, I'll select None. Then I'll click Create Function. Next, I'll invoke the Lambda from the Test tab. And we get results. In VS Code, I've got my new index.py file that returns a basic response. I'm importing Boto 3, which is the AWS SDK for Python, along with other required imports. Then I set up some basic error handling, and since we'll be invoking the Lambda with a prompt, I get the prompt from the event body. Then I create a new instance of the Bedrock client. Then I create a retrieve and generate command, and in the configuration, I'll specify the knowledge base ID, which I'll get from an environment variable which I can set later. And for the LLM model, I'll specify the ARN of the Claude 3 Haiku model. Then I invoke the retrieve and generate command and set it to the result variable. And finally, I return the results. Back on the Lambda page, in the Code tab, I'll click the Upload From button and select Upload. And then I'll select the zipped deploy file. And under Runtime Settings, I'll click Edit and change the handler to index.handler, since both the file name and function name change compared to the default lambdas, file name, and handler. Since lambdas have a default timeout of 3 seconds, I increase this timeout by clicking on the Configuration tab, General Configuration, then Edit, and change the timeout to 30 seconds. And then I'll click Save. Then, to set the knowledge base ID as an environment variable, I'll click Environment Variables, then Edit. I'll give the key a name of knowledge base ID, and the value should be the value of the knowledge base ID. Now I'll head back to the Test tab, and I'll invoke the Lambda with a new payload that includes the prompt. I get an access denied exception, and this is because the Lambda doesn't have permissions to invoke AWS Bedrock. I'll copy the IAM role name that is listed in the error, then I'll go to the IAM console and click on that IAM role. Under Permissions Policies, I'll click Create Inline Policy, and then I'll click on JSON. Then I'll add this inline policy, which will give my Lambda the necessary permissions to invoke AWS Bedrock. I'll click Next, and for policy name, I'll give it a name and click Create Policy. Back on the Lambda's Test tab, I'll click the Test button, and now we get results. Now that the Lambda is functioning as an API, let's build a sleek ChatGPT UI. I'll use Streamlit. Let me take you through the code. In my main function, I'm importing all the necessary modules, Streamlit for the UI, invoke Lambda to call the Lambda function, and load CSS, which loads the CSS file. Then I initialize a session state variable called chat history to store the conversation. The main function sets the page configuration and loads custom CSS for styling the chat interface. The chat history is then displayed, iterating through each message and styling the user and bot messages. The text input field at the bottom of the UI allows the user to send a message to the chatbot. When the user sends a message, it's appended to the chat history and displayed on the screen. The bot's response is generated by calling the AWS Lambda. A placeholder is used to show a spinner while the request is in progress, and then the response is added to the chat history. And finally, there's a clear chat button to clear the conversation history. One final note. Since we're dealing with private data here, we don't want to expose our data to the public on a public API. There's two options here. The most secure option would be to put API Gateway in front of the Lambda. And you can configure API keys with API Gateway along with IP address restrictions. The easier way to do this would be to add an API key as an environment variable and then validate for the authorization header in the post request right here in the Lambda. To see how I do this and get the source code for this code, head over to my blog post, which is listed in the description below. If you found this useful, please like, comment, and subscribe, and I'll see you in the next one.